Welcome to part 3 of the Digital Electronics Whiteboard Talks. In this video, you will learn why area scaling is important and how to know if it is adjusted correctly. What is area scaling? First, a voltage pulse is created when a cell crosses the laser. At this point, the height and area measurements of the voltage pulse are determined. To digitize the analog voltage pulse, measurements are taken 10 million times per second. The maximum measured signal for a voltage pulse is recorded as the height measurement. The area is determined by adding together all of the measurements for one pulse. Both the area and height must remain on scale to accurately measure the signal. By default, the area measurement is displayed in the software, but the height might not match the area.
What happens to the area if the height is off scale?
If the height is off scale, then the detector is saturated and the signal is outside of the linear range. And because the height is part of the signal that makes up the area, if the height is outside of the linear range of the detector, then the area measurement cannot be measured accurately, even if it appears that the area is on scale.
Does it cause a problem if the height is lower than the area?
If the height is too low, then the signal might be affected by electronic noise, resulting in decreased resolution of dim signals from noise. And again, if the height is not measured accurately, then the area will also be affected.
How can I verify that the area and height will both remain on scale?
Before optimizing the detector voltages, you can use area scaling to adjust the area to match the height. Once this has been adjusted, both signals will move as you adjust the voltages, so even if you're not looking at the height, it will remain on scale.
When do I need to adjust area scaling?
One of the factors that affects the relationship between area and height is particle size. Area scaling is first set when running a performance check in CS&T based on the CST beads, which are small particles compared to most cells. When a cell or particle crosses the laser, measurements are taken based on time increments of 10 million times per second. When you run a cell that is larger, it takes longer to cross the laser, which changes the shape of the voltage pulse and increases the number of measurements collected for that pulse. Even if two particles have the same fluorescence and thus have the same height measurement, the area will not match because more measurements are collected for a larger cell, resulting in a larger area signal. The area of some large cells might not be able to be measured on scale in forward scatter until area scaling has been adjusted. So if you're running large cells and are unable to get them on scale in forward scatter, check the forward scatter area scaling. Another factor that influences area scaling is sheath velocity. The sheath velocity can be changed on a cell sorter with variable sheath pressure. At high sheath pressure, a cell will pass quickly through the laser. At a lower sheath pressure, the same cell takes longer to cross the laser, resulting in a larger area signal. You should adjust the area scaling anytime you run large cells on a DIVA-based instrument, or if you change the sheath pressure on a cell sorter, such as the BD FACSDiva. This concludes part 3 of the Digital Electronics Whiteboard Talks. For more information on digital electronics, refer to the BD FACSDiva option white paper or your instrument's user's guide. Be sure to view parts 1 and 2 of this series. Thanks for watching.